Hello everyone, this is Pravashri, Department of Mathematics, SNS College of Technology. So today we are going to see some definitions of tautology and contradiction. So tautology is nothing but a given statement is true for all possible values of its proportional variables is called a tautology. So our final answer will come as a true. That is a main condition in tautology, or a universal valid formula or a logical truth. So it must be a true value, then it is called as a tautology. So for example, they have given this p or negation p is a tautology. We can see as an example in the following steps. So the next one is a contradiction. If a contradiction means in the name itself it is a having, so tautology means we will have the statement as a true, so contradiction means opposite to that tautology. So a statement is always false, it is considered as a false, always it will be a false, it's an universal false. Okay, then it is called contradiction. Okay, a statement that is always false is called a contradiction or absurdity. Okay, for example, p and negation p is a contradiction. So contingency means a proportional function that is neither a tautology nor a contradiction. It can't be whether we can't say that is a true or false statement. For an example, if you like ice cream, I can't say whether it is a true or false statement. Then that type of statements are called contingency. Now we can see the example for contingency is p biconditional q is a contingency one, because p biconditional q means biconditional means if both statements p and q both statements are true means it will leads us to true. If a single statement is a false means it leads us to a false statement. If both statements are false also leads us to a true. Okay, so they have given as an example p implies q. So note the negation of a contradiction is a tautology. So negation of a we know that a false statement, negation of a false statement which is implies true. Okay, now we are going to show that p and negation p is a tautology. So we are going to apply a truth table for the both statement. So p or negation p. Now we are going to they have given a single statement. So our formula is 2 power n. So here we are having a single statement as a p. So 2 power 1 which is equal to 2. So we are going to apply a two values, true and false here. So for p we are applying true false. So negation p is nothing but opposite to the p. So true implies false and false implies true. So now p or negation p is nothing but if any one value is true, then p or negation p is also true. So true false implies true, and then false true implies true. Then the given statement is a tautology. Now we are going to find same statement for p and negation p, and that statement leads us to a contradiction. So p and negation p is nothing but true false implies false. If any one of the value is false leads us to a false in the statement. Okay, so true and false means false, false and true means also false. So hence the given statement p and negation p leads us to a contradiction. So the next one is we are going to prove that the given statement p or negation p and q is a tautology. Okay, let's see whether this the given statement is tautology or not. Now we are going to find the value for p and q. Then we are going to find the negation p and q, and the final answer will be a tautology. So here they have given two statements. So p and q. So our formula is 2 power n. So 2 squared, which is nothing but 4. So we are going to fill 4 values for p and q. So p is nothing but true, true, false, false, and q is nothing but true, false, true, false. So p and q, which implies true and true, true, true and false, which is implies false, false and true, false, false and false, false. So negation of the given statement is true comes means it leads us to a false. So false, true, true, true. Okay. Now we are going to find P or negation PRQ. If any one value is true, then it leads us to true. So true, false, true, 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 false, true, true, false, true, true. So the given statement is a tautology, hence proved. Thank you.